Hello students, in this video I will explain some other results on the continuous function. First one is algebra of continuous function. These results are very simple. That is, suppose f and g be two real functions continuous at a real number c, then first result is f plus g is a continuous function at x equal to c, f minus g is continuous at x equal to c, f into g is continuous at x equal to c, and f by g is also continuous at x equal to c provided g of c is not equal to 0. And these result you have to memorize, and you can apply this result for verifying the continuity of the function at x equal to c. And in addition, now as a special case of 3 above, if f is constant function, that is f of x equal to lambda for some real value of lambda, then the function lambda into g, that is defined by lambda into g of x, that's equal to lambda g of x, is also continuous. And in particular, if lambda equal to minus 1 and f is continuous, minus f is also continuous function. Now we will have some important results. The first one is show that every polynomial function is continuous, and you have to remember this result. Recall that a function p is a polynomial function if it is defined by p of x is equal to a0 plus a1x plus so on an x to the power n for some natural number n, where an is not equal to 0 and all ai's belongs to R. Here a0, a1, an are all real numbers. N should not be equal to n should be a natural number. N should be a natural number and an is not equal to 0, which is a definition of the polynomial. And clearly this function is defined for every real number. Polynomial function is defined for every real number. For all x, p of x is defined. And for a fixed real number c, we have limit extending to c p of x is equal to p of c. This you already studied in limit, and limit of the polynomial is equal to value of the polynomial. Therefore, the polynomial function is a continuous at x equal to c, and c is any real number, and p of x is continuous at every real number, and hence the p of x is a continuous function. That is, polynomial function is a continuous function, and you remember this result. And let us take the trigonometry function. First, let us discuss the continuity of sine function. And see here, we have a limit extends to 0 sine x equal to 0. And by using the graph, it is very easy to come to the conclusion that limit extending to 0 sine x equal to 0. See here, the graph of sine function is like this. As x tends to 0 from the right side of 0, that is x tends to 0 plus, and sine x is equal to 0, you can observe the, and as x approaches 0, sine x becomes smaller and smaller and it will become 0. It approaches 0 from the right side. If x tends to 0 from the left side of 0, that is limit extending to 0 minus, then also sine x approaches 0. Thus we will have limit extends to 0 sine x equal to 0, and you should use this result for discussing the continuity of sine function. Similarly, limit extends to 0 cos x is equal to 1. See this graph. Graph of the cos function is like this. As x approaches 0 from the right side of 0, and cos x is approaches 1. And similarly, as x approaches from the left side of 0, cos x approaches 1. Here limit extends to 0 cos x is equal to 1, and we will use these two results for verifying the continuity of the function at x equal to c. And now let us take the function f of x equal to sin x, and it is defined for every real number. And let c be a real number, and we have to find limit extends to c sin x, and we have to show that limit extends to c sin x is equal to sin c. Here put x equal to c plus h. If x tends to c, we know that h tends to 0. And let us take limit x tends to c f of x, that's equal to limit x tends to c sin x. And what is x here? X equal to c plus h, and replace this x by c plus h. It will become limit h tends to 0 sin of c plus h, because as x tends to c, h tends to 0, and this will become limit h tends to 0 sin of c plus h. And that is limit x tends to 0 f of x is equal to limit h tends to 0 sin c cos h plus cos c sin h. That is sin of x plus y is equal to sin x cos y plus cos x sin y. That formula is applied here. And that is equal to sin c is constant, limit h tends to 0 cos h, plus cos c is constant and limit h tends to 0 sin h. And you know that limit h tends to 0 sin h is equal to 0, and limit h tends to 0 cos h is equal to 1. And substituting here, sin c into 1 plus cos c into 0. Cos c into 0 is equal to 0, sin c into 1 is equal to sin c, and that's equal to sin c, and which is equal to f of c. Limit x tends to c, f of x equal to f of c. Therefore f is a continuous function. Similarly, if you take f of x equal to cos x, which is also a continuous function, and by using these two results, and it is possible to verify the continuity of the other trigonometric function, and other trigonometric function are all ratio of these two trigonometric functions or the reciprocal of trigonometric function, and all trigonometric functions are continuous function in its domain, and continuity in the domain of the function. Now let us come to the other result, that is continuity of composite functions. Suppose f and g are real valued functions such that f composite g is defined at c, g is continuous at c, and f is continuous at g of c, then f composite g is also continuous at x equal to c. And see this problem. Show that the function defined by f of x equal to mod cos x is a continuous function, and let g of x equal to cos x and h of x equal to mod x. And you know that all trigonometric functions are continuous function. Cos x is continuous function, and mod x is also continuous function. And let c be any real number, and g of x is continuous at x equal to c, and h of x is continuous at x equal to g of c. Here h of x is continuous everywhere, and g of x is a real number, and g of c is also a real number. H of x is continuous at x equal to g of c also, and here h of x is continuous here h of x is continuous at c also, but we will take at x equal to g of c, because to apply the concept of continuity of composite function, and this is the condition, that's why we have taken h of x is continuous at x equal to g of c. Hence h composite g is continuous at x equal to c. That is h composite g is a continuous function because c is any real number, and it is continuous at x equal to c, and c is any real number means it is a continuous function. That is h composite g is continuous function. And what is h composite g? H composite g means h of g of x is continuous function. What is g of x? G of x equal to cos x. Therefore h of cos x is continuous function. And here what is h of x? H of x equal to mod x. What is h of cos x? Mod cos x is a continuous function. And this is the method of proving that composite function is a continuous function. Here first you have to show that the function is continuous, and then you have to show that composite of the function is also continuous. And with this much I will conclude this video, and in the next video I will tell one more concept, that is differentiability of the function at x equal to particular point. In the next video I will explain the differentiability of the function. Thank you.